Okay, I hope you're able to see the screen. Sometimes I never know if it's on my ladybug or not. Figured out the ladybug problem. All right, now we're going to be talking about density. All right, and density is kind of tricky, and especially when we're doing these volumes of small objects. So let's just practice one because you've got an assignment. In fact, I show you a home run. Moose Moustakas hits a home run. It's not as good as when Trout hit one against us in 2015 in April of 15, and that was back when the Royals were like bad. April of 15. Then all of a sudden in June, you know, the Ned Yost method finally kicked in with them, and they realized, hey, we don't suck as bad as other people. We can probably win some ball games. And then they had the great relievers. They're like, hey, as long as we're ahead by 2 runs, except for yesterday, as long as we're ahead by a couple runs, we'll shut them down in the seventh, eighth, and ninth. That's their formula. We'll play great defense and shut them down. Anyway, but Trout hit this home run, and they actually showed the ball in the fountain. And I might try and find that here in a minute because one of the files that I have on there for you is the ESPN home run tracker, which we're going to go to soon. But density is kind of tricky, and here my boss has done a good job of on this slide of showing you how to do it. But I want to show you how to do it using. So let's find like the density of a golf ball. Will a golf ball float? First of all, if the density of something and lower density materials float in higher density fluids. So like these lava lamps, they get hot. What happens is they get hot. The material expands. Sometimes it expands and breaks away, and so they get bigger, and then they float to the top. They cool off, and they come back down. Go to the top, cool off, come back down. I've got what is known as a Newton's thermometer that does basically the same thing too. As a matter of fact, I'm going to show you a picture of it right now when I go to the ladybug. There it is. Now it's sitting on its side, so it's kind of screwed up. It's actually supposed to sit like this, and then you look at it like this. Wow. Am I messing with your heads here enough or what? So here it is. I have no, so why did I do it that way? Why not just, because it's in a fluid, so it'll stay the same anyway. Well, kind of. But anyway, these things, based on their temperature, the different fluids in them the air above gets either more dense or less dense. And when it gets less dense, they fall through the fluid. And then when it gets more dense, they go up. And so if it gets really hot, then those things go up, and they stay within the degree thing. A very nice young lady gave me this as a gift for, I guess she thought I helped her out, you know. She was kind of in a tight squeeze there with her classes a little bit. But anyway, so let's figure out, first of all, let's find the dimensions of a golf ball. Since this is sports class, we might as well find the dimensions of it. So let's find the dimensions of a golf ball. And let's see if a golf ball will float. All right, so we're going to go up here. Dimensions of a golf ball, 42 millimeters in diameter, and it has a mass of 45 grams. All right, let's call it 43 millimeters in diameter, and let's call it a mass of 46 grams, just for a ballpark. So 43 millimeters, 46 grams. Let's find the mass of a golf ball. All right, so that's what we're going to do. So mass of a golf ball, or density of a golf ball. And density, what it equals, density is equal to mass over volume. And it's the thing is rho. So we found that the golf ball had a density of 46 grams. It had a mass of 46 grams. So 46 grams, got to convert that to kilograms. So when we convert to kilograms, we have to divide by 1,000. So that'd be 1, 2, 3. So we get 0.046 kilograms. All right, that's the, I want that to be focused a little bit better. I think whacked it out of focus. There we go. There's a good old focus on it. See, that seemed to get better, didn't it? Uh-oh. There we go. All right. That's... Oh, here we go. Here's how you focus. Go in. Yeah. I like that better. Then you click on this again, and then it goes away. Open that up. There. That's a much better picture. Oh, wait. I figured out what it was. I didn't have my glasses on. All right. Can I waste any more of your time today? Can I? Oh, man. What a maroon. All right. So anyways, 0.064 kilograms. The diameter of it, hell, I forgot what it was now. Oh, we're going to go with 44 millimeters. I don't remember what it says. Something like that. Because both of them were 40 something. So 44 millimeters. And so that means the radius is 22 millimeters. And millimeters, not 22 meters. That'd be a hell of a golf ball. 22 meters. And then that is equal to 0.022 meters. Now, let's find the density. The first thing you got to do, first thing we're going to do is here's the way you would do it on your calculators. You'd say, okay, well, the density rho is equal to mass. You type in parentheses, 0.046. I do everything in parentheses. Divided by parentheses, pi, 3.14. If you have the pi key, you can go ahead and push that. Put parentheses around it. Times 0.022, 0.022, 0.022. Now look, I've got 1, 2, 3, 4, 5 parentheses open, and I've got 1, 2, 3, 4 parentheses closed, so I better close it one more time. So what I've done is I've taken this entire part and dividing it by this part. So these two parts now, and if you're a little more sophisticated with the calculator, I'll show you a different way to do it. But for right now, this is the fail-safe way. All right, you can't go wrong. I know some math teachers might go, well, they need to learn how to take it. Go teach the other 15%. All right. Anyway, so here we go. So we've got 0.046 divided by parentheses, pi, if you have a pi key. I'm going to put in my pi key because it's fun to do. Put in my pi key. Close the parentheses. 0.022, 0.022, because the parentheses act like multiplication. There's two of them. Let's do one more. Close, close. Enter. There we go. Is that right? I bet you it is. I bet you it is. That's right. So, there's the density of a golf ball. It's lighter than air. In fact, I came up with the density of air. I did not mean to, but that looks like what I did. So let's see let's verify and see if it's right. Let's see if that is the same thing as 0.046 divided by, or 4/3. So the volume of something is 4/3. Oh, that's not even close. There's your volume for something round. Pi r cubed. I forgot to multiply by 4 and divide by 3. So what we'll do is, forget I did this. And let's go, this is track 11. Let's go to track 12. All right.